Hello everyone. Today we are going to discuss about the numerical problems based on pH value of the solutions. After going through the video, students will be able to understand to calculate the pH of strong acids from given concentrations of hydrogen ions, to find out theoretically pH of resultant solution in which acid and bases are mixed, to find out hydrogen ion concentrations from given pH values using log table, to calculate pH value of strong bases, to calculate pH of very dilute acidic solutions. Let us take the problem of calculating pH value of a base, that is calcium hydroxide, in 500 milliliter of the solution. Calcium hydroxide is a strong base. It completely dissociates into calcium ions and hydroxyl ions. The concentration of calcium hydroxide is given, that is 0.3 gram in 500 milliliter of the solution. We have to find out hydroxyl ion concentration. So first of all, we will find out the concentration of calcium hydroxide in terms of moles, molar concentration, number of moles divided by molar mass, volume of the solution, and therefore this will comes out to be 0.6 upon 74. It comes out to be 0.08 molar. We can see here that 1 mole of calcium hydroxide gives 2 moles of hydroxyl ions. It means hydroxyl ion concentration will be twice the concentration of calcium hydroxide, that is twice into 0.008 molar, that is it comes out to be 0.01016 molar. So we will find out POH minus log of hydroxyl ion concentration, and this comes out to be minus log of 0.016 molar. We will see the log of this number, and the POH value comes out to be 1.7959. We know that pH and POH sum is equal to 14, and pH is equal to 14 minus 1.7959, that is 12.2041. So this is the pH value. Now let us take the problem of hydrochloric acid, in which the concentrated hydrochloric acid is diluted to 1 liter of the solution. HCl is a strong acid and it completely dissociates into hydrogen ions and chloride ions. It means 1 mole of HCl is going to give 1 mole of H positive ions. To find out the final concentration of resultant solution, we will use the molarity equation M2V2. Let us say this is the given solution's molarity and volume, and this is the required solution. Given solution has a molarity of 13.6, volume is 1 milliliter. Final molarity of solution we have to find out, and the solution changes to molarity is 13.6 divided by 1000, that is it comes out to be 1.36 into 10 raised to minus 2 molar. So this is the molarity of hydrochloric acid. Now the pH of resultant solution is minus log of H positive ions, that is minus log of 1.36 into 10 raised to minus 2, and if we solve this equation it comes out to be 1.8665. So this is the pH of the resultant solution. Now let us take the example of very dilute hydrochloric acid. Here, hydrochloric acid again dissociates into completely dissociated the hydrogen ions. Concentration of HCl is 1 into 10 is to minus 8 molar. Therefore, hydrogen ion concentration is also equal to concentration of HCl. That is this. Now, pH is equal to minus log of 1 into 10 raised to minus 8, and if we solve this it comes out to be 8, but pH is greater than 7. It means the solution, therefore solution should be basic in nature, but HCl acidic in nature. This is acidic solution. So this method of calculating the pH is wrong. How to find out pH of this type of solution? Here we have to take into consideration the dissociation of hydrogen ions and dissociation of water into hydrogen ions and hydroxyl ions. So the hydrogen ions not only come from HCl, they also come from the dissociation of water. Let the concentration of hydroxyl ions and hydrogen ions obtained from water are X. So total hydrogen ion concentration is equal to 10 raised to minus 8 plus X. So according to ionic product of water, product of concentration of hydrogen ion, hydroxyl ion concentration equal to 10 raised to minus 14. So it comes out to be 10 raised to minus 8 plus X into X equal to 10 raised to minus 14. Now it changes into the quadratic equation, 10 raised to minus 8x minus 10 raised to minus 14 equal to 0. And if we solve the value of x for this equation, it comes out to be 9.5 into 10 raised to minus 8. And this is the concentration of hydroxyl ions. And the pH of this solution is equal to like this. So from here we will find POH equal to 7.02 and pH is equal to 6.98, which is correct. Now let us take up the example of mixture of two solutions. One is the acid and another is base. So the question is, what will be the pH of resultant solution in which H2SO4 and calcium hydroxide are present? Now let us see what reaction takes place actually between calcium hydroxide and H2SO4. Neutralization reaction actually occurs between the two, forming salt and water. So 1 mole of calcium hydroxide reacts with 1 mole of H2SO4. Now let us see how many moles of H2SO4 are present in 10 ml of 0.01 molar H2SO4. Molarity is equal to number of moles upon volume in milliliter into 1000. So the number of moles of H2SO4 are equal to 0.01 into 10. So it comes out to be zero point 1 into 10 raised to minus 3 mole. Similarly, number of moles of calcium hydroxide present in 10 milliliter of 0.01 molar calcium hydroxide. So 0.01 into 10 milliliter divided by 1000 comes out to be 0.1 into 10 raised to minus 3 moles. So from here we can see that equal number of moles of calcium hydroxide and H2SO4 are present. So the hydroxyl ions and the hydrogen ions will combine together to form water, that is the neutral solution. So overall solution will be neutral, and the pH value of neutral solution is 7.